Hello everyone, my name is S.N. Patil. In this video lecture, we discuss the Laplace transform of multiplication by t. That is simply multiplication by t property. Okay, what is the property? If the Laplace transform of f of t is capital F of s, then the Laplace transform of t raised to n is integer, f of t is equal to minus 1 raised to nth derivative of capital F with respect to s. Okay, now prove. We know the definition of Laplace transform. The definition of Laplace transform of the function f of t is equal to capital F of s is equal to 0 to infinity e raised to minus st f of t with respect to t integration. Say equation number 1. Now here we differentiate equation 1 with respect to s. Okay, differentiate equation 1 with respect to s. That is the derivative of capital F with respect to s is equal to the derivative of integration e raised to minus st f of t with respect to t integration. Okay, is equal to. Now here we use DUIS rule by DUIS rule. DUIS rule means what? Differentiation under integral sign rule. Okay, when it come under integral, then it become partial derivative. Okay, that is partial derivative with respect to s e raised to minus st f of t and the integration t. Okay, so here in differentiation under integral sign rule, the limit is constant, so that we only differentiate the term. Okay, so here derivative of the square bracket with respect to s partial derivative. Other variable treated as constant, that is f of t is constant, only a derivative of e raised to minus st. Okay, it can be written as 0 to infinity. The derivative of e raised to minus st is e raised to minus st. Again, derivative of the power with respect to s. The derivative of minus st with respect to s is minus t and f of t dt. Okay, limit is constant here, so that there is no need of the next term. Okay, now here minus sign is constant, minus sign is outside 0 to infinity. Okay, e raised to minus st and here t into f of t dt. Okay, now see from equation 1, if f of t is here, then we write f of t here. If t into f of t, then definitely t into f of t. Now it can be written as derivative of capital F with respect to s. With respect to s is equal to minus, and this is Laplace of t into f of t. Okay, so this is the Laplace transform of multiplication by t. Otherwise, we can write as the Laplace transform of t into f of t. F of t is equal to minus derivative of capital F, and capital F is a function of s. Okay, so this is the particular result for n is equal to 1. Okay, now we find the Laplace for the t raised to 2. T raised to 2. Now using this result, the Laplace transform of t square into f of t is equal to, so t square we write as a t into t. t into t f of t. Okay, and we know t into function. See here, we have the result. T into function is minus derivative of f of s. Means f of s means what? F of s means Laplace of f of t. Okay. So instead of f, we write Laplace of f of t. So it can be written as minus d by ds, and derivative of this f of s, here its Laplace is f of s, t into. So instead of that, we write Laplace of t into, because we don't know what is the simplified step, we write t into f of t. Okay, and we know the Laplace of t into f of t minus d by ds. The Laplace of t into f of t we just calculate as a minus d by ds. Okay, into f of s, into Laplace of f of t, into Laplace of f of t. That is, the Laplace of f of t means f of s. Now here this minus, so it can be written as 2 times minus sign, minus 1 raised to 2. Okay, and it become second order derivative. And Laplace of f of t, we write f of s. Okay, that is Laplace of t square into f of t is equal to minus 1 raised to 2 second order derivative with respect to s into f of s. Now using mathematical induction, okay, we can make it generalize. Laplace transform of t raised to n f of t, okay, is equal to minus 1 raised to n nth derivative with respect to s, nth derivative with respect to s of f of s. So this is the Laplace transform multiplication by t raised to n. Now let us take the example. Laplace transform of Laplace transform of t into sine of t. Find Laplace transform of t into sine of t. So what is the property? If t into f of t is there, then first calculate Laplace of f of t, which is f of s, and then take the derivative of f of s. Okay. So here f of t is equal to, here f of t is equal to sine of t, and we know Laplace of f of t means Laplace of sine t is equal to f of s, and the Laplace of sine t is 1 upon s square plus 1, and we write 1 upon s square plus 1 as a f of s. Then Laplace of t into sine of t is equal to minus, by property, d by ds into f of s. Okay, it can be written as minus d by ds 1 upon s square plus 1. Okay, is equal to, now derivative of 1 upon function is, we know that derivative of, so I am not writing with respect to what, derivative of 1 upon function is minus 1 upon function square, again derivative of function. Okay, so 1 upon function is s square plus 1 is minus 1 upon function square. Okay, again derivative of function, the function is s square plus 1, the derivative of s square plus 1 is 2s. That is the Laplace transform of t into sine t is equal to, here minus minus plus. Okay, so what is remaining term in numerator? Simply 2s divided by a square plus 1 bracket square. Okay, now second example, Laplace transform of t into e raised to 2t. Okay, so we write as a function t into f of t. To identify f of t is equal to e raised to 2t. So first calculate Laplace of f of t. Laplace of f of t. Laplace of f of t is equal to Laplace of e raised to 2t is equal to capital F of s, means Laplace of e raised to 2t is 1 upon s minus 2. Okay, this is the f of s. Now by definition, Laplace transform t into e raised to 2t by multiplication by t property, multiplication by t. Okay, similarly here by multiplication by t property is minus d by ds, d by ds into f of s is equal to minus d by ds. The value of f of s is 1 upon s minus 2. Now apply same rule. Derivative of 1 upon function is minus time 1 upon function square, again derivative of the function. It can be written as, keep minus sign as it is, minus 1 upon function square. Okay, again derivative of this function with respect to s. With respect to s, the derivative of s minus 2 with respect to s is 1. So here minus minus plus, so we get Laplace transform of t into e raised to 2t. E raised to 2t is equal to 1 upon s minus 2 raised to 2. Okay, thank you.